here's another example. Find the coordinates and nature of stationary points on this curve. So the first step is to find the first and the second derivative. So step 1, find the first and second derivative. So the first derivative is okay, let me use a different color. So the first derivative will be 4x cubed, and the second derivative will be 12x squared. Okay, step 2. We need to find the critical values of x by setting the first derivative equal to 0. So find the critical values of x by setting the first derivative equal to 0. What I mean by that is you take the first derivative, which is 4x cubed equal to 0, solve it, and you find that x equals to 0. And that is the critical value of x. Step 3, use the second derivative to determine maximum and minimum points. So use the second derivative, and this is now where we're applying the second derivative test. So use the second derivative to determine maximum or minimum point. Okay. So which means we are going to take our critical point and plug it into the second derivative, and of course if we plug that into the second derivative, that will be 0. So the second derivative fails. Okay, so the second derivative fails, so the test fails, hence we apply the first derivative test. Hence we apply the first derivative test. So the first derivative test is the one whereby you have to draw the sign diagram. Okay. So you have a sign diagram of x values, but what we want is the signs of the gradient. Okay, that's what you're interested in. Okay, so just need to write this properly. So what you're interested in is the sign of the gradient. Yeah, that's better. Okay, so our critical point is 0, which means we need to pick test points. We can pick a test point here, we can pick a test point here, and we can pick a point like -1, which is easy to deal with. If you plug -1 here, you'll end up with now remember you're plugging the first derivative. You'll end up with -4. If you plug in 1, you'll end up with 4. So we can notice that the first derivative is actually changing. So here it's negative and here it's positive. And in fact, Negative here means you are going downhill, positive means you're going uphill. So what we have is a minimum point. So we can say that our conclusion, we can say that at x equals to 0, what do we have? The slope is changing from negative to positive. So f dash x changes, or the slope changes from negative to positive. And therefore we have a minimum point. So hence minimum point. So what will be step 4? Step 4 will be find the y coordinate. So the y coordinate, we just plug in 0 in place of x. So if you plug in 0 in the original function, you get 0. Okay? So which means that 0, 0 is the minimum point. Okay. Next example. So we are given a rational function. Use the fact that the first derivative is equal to that to show that the second derivative is equal to that. So that's A. B, we need to find the relative extrema. So this means just maximum or minimum point. Okay. So what will be the process here for A? For A, we just need to differentiate. So there's no step 1 or step 2. It's just differentiating. So we know that the first derivative is equal to negative 48 x over x squared plus 12 squared. And let this be equal to our u and v. Now we know that dy over dx quotient rule is equals to v du over dx minus u dv over dx over v squared. Okay, so what we need to do here, we need to apply this, plug this stuff. So our second derivative will be equal to x squared plus 12 squared. That's a square. D over dx into negative 48x minus negative 48x d over dx of and I think here I'll use this kind of brackets, x squared plus 12 squared. All this over v squared, which is x squared plus 12 squared squared. Okay, so we need to work this out, which leads us to the next step. So the next step will be x squared plus 12 squared. Now if we differentiate negative 48x, just negative 48 minus negative 48x. Now we have to apply chain rule here, which will be 2 into x squared plus 12. And so outside and then inside we have 2x. Done. All this over x squared plus 12 to power 4, because a power over power, you just multiply the powers. All right, let's carry on. So this will be equal to, we need to FOIL here. So actually I'm not going to FOIL it. But what I'm going to do here is, because if you look at the question, you're supposed to show something here. All right. this bit. So which means, and the fact that if you look at this bit here, we have x to power 3. Actually, I don't need to get a highlighter. We have x to power 3 here. So I need to find a way of cancelling a few stuff, factorizing and cancelling. So what I'm going to do here is, okay, grab a highlighter. I'm going to factorize this guys here. Okay. So if I factorize that out, what I'll end up with is x squared plus 12 outside the bracket, and then inside the bracket, actually let me use x squared plus 12 outside, and then here I'm going to use these guys here. So what I'll have is x squared plus 12 multiplied by negative 48 minus, and here I have negative 48 x multiplied, I have 2, and then I have 2x, close the bracket. All this over x squared plus 12 to power 4. Okay. Now, what I need to do next is to cancel a few things here. That and that cancels to get x squared plus 12 to power 3, which means I'll end up with, so now I can FOIL a few things. So that will be negative 48 x squared minus 576, which is 12 multiplied by 48, plus multiply all those guys, 192 x squared over x squared plus 12 cubed. These are like terms. This one here and this one here. So we can put them together. So which means I'll end up with 144 x squared minus 576, all this over x squared plus 12 cubed. Now you can go ahead and factorize out 144. So you'll end up with x squared minus 4 over x squared plus 12 cubed. All right, so that's done. Now, part B, we need to find the maximum and minimum points. So, which means part B of this question, we need to find maximum and minimum. So, step 1 is we need to find the critical values of x. So, find the critical values of x by setting the first derivative, or just equating the first derivative equal to 0. Which means our first derivative that we had calculated, no, actually that we were given in the question, was negative 48x over x squared plus 12 squared. Equate that to 0. So what you'll end up with is negative 48x is equals to 0, which means x is equals to 0. Okay? And then step 2, we need to apply the second derivative test. Okay? So use the second derivative to determine if the point is maximum or minimum. Okay, so what do we need to do? We need to take our critical point and plug it into the second derivative. So at x equals to 0, what will be the value of the second derivative? So you can just do that. Take it, plug it into the second derivative. You have the second derivative here in the question. Fortunately, you don't have to work it out. You just plug it in there. And what you end up with is negative a third. And this is a maximum. And that's why we need the second derivative test. Okay, it tells us if maximum or minimum. So it's a maximum since the second derivative is less than 0. Remember, it's opposite of what you expect. Now, final step, which is step 3, find the y coordinate. Step 3, find the y coordinate. So we'll go ahead and say f of 0. So you're plugging 0 into the original function. Okay? So f0 will be equal to 2, which means that 0, 2 is the maximum point. Remember how you have maximum, so maximum point.